In this video, we will learn how to compute percentiles. On each trial of an experiment, a subject is presented with a constant soft noise, which is interrupted at some unpredictable time by a noticeably louder sound. The time it takes for the subject to react to this louder sound is recorded. The following list contains the reaction times in milliseconds for the 20 trials of this experiment. 152, 186, 229, 261, 236, 273, 171, 231, 241, 222, 271, 202, 226, 257, 175, 235, 164, 250, 311, and 269. We must compute 25th and 80th percentiles. ALEKS shows you two methods of computing percentiles. I'm going to use what they call method 1. First, we're going to compute the product of n sample size with a quotient of p over 100, where p is the percentile we are computing. This quantity will be called L. That's how it's called in our textbook. L will represent the position in our data set when data are arranged in order from least to greatest. If the quantity we got is a whole number, we need to find the average of numbers in position L and the position next to it, L plus 1. Then that average will become our quantity for that percentile. If it happens that the result of the product above is not a whole number, all we need to do is round it up, round that quantity L up to the next whole number, and pth percentile will be the number in that Lth rounded to the next whole number position. Let's take a look how this will be done in our case here with this data set given to us. First, I note that there are 20 elements in my data set, so n is equal to 20. Then I arrange all my elements in order from least to greatest. Now I'm ready to start computing L. L is equal to sample size n multiplied into this particular percentile we're looking for, and I'm working on 25th percentile at a time, so 25 over 100. This product yields 5. Since 5 is a whole number, I need to find the average of numbers in position 5 and the next to it 6 position. So I need to go to my ordered data set and find which numbers are in 5th and 6th position. Number 186 is in the 5th position and 202 is in the 6th position. I need to find the average of these two quantities, and that will give me the 25th percentile. The average is 194, therefore 25th percentile is 194. You would type that quantity in there. Let's compute our 80th percentile this time. Just like before, I'm computing quantity L by multiplying sample size 20 into the 80th percentile over 100, so 80 over 100. This product yields 16. Because again, it's a whole number, to find the 80th percentile, I need to find the average of elements in my data set that are in the 16th and the position next to it, 17th position. The two numbers that are in the 16th and 17th position are 261 and 269. I need to compute the average of these two numbers. This average comes out to be 265. Therefore, we found that 80th percentile is 265 for this data set. The following are the PE ratios. Price of stock divided by projected earnings per share for 17 banks. 38, 18, 29, 15, 14, 21, 22, 23, 31, 18, 24, 22, 23, 14, 15, 20, and 43. Find 25th and 60th percentiles for these ratios. Just like before, I note the sample size, which is 17, and I arrange my data elements in order from least to greatest. Now I will work on computing the 25th percentile for this data, and my first task is to find quantity L. Recall that L is computed by multiplying sample size into P over 100, where P is the percentile you're working with currently. In our case, L is equal to 17 times 25 over 100, which came out to be 4 and 25/100. Remember, if you get a number that is not a whole number, all you need to do is round it up to the next whole number, which is 5 in our case. It means that 25th percentile will be a quantity in the 5th position when your data is arranged in order. So I have number 18 in the 5th position, so 18 must be the answer for this first question. Let's do similar process for the 60th percentile. We need to compute L, sample size 17 times 60 over 100. This quantity comes out to be 10.2, and when I round it up to the next whole number, 11, it means that 60th percentile is number in the 11th position in my data, and it happens to be, let's take a look. This is 5th, 6th, 7th, 8th, 9th, 10th, 11th. It happens to be this 23 right there. So 23 is the answer for the second part of this question. I would like to note that the 25th percentile is same as quartile 1, 50th percentile is same as the median, and 75th percentile is same as quartile 3. We already saw quartile 1, median, and quartile 3 when we learned about 5-number summary and when we learned how to build box and whisker plots.